U-Substitution. Good stuff. U-Substitution. What is that? All right, so we know how to take the antiderivative, but only in very rare cases. It seems like you know how to take a lot of antiderivatives, right? Because we've been doing it for a while. But only when it's a power, like an exponential, or, sorry, a polynomial function, or if it's something that you just know how to take the antiderivative of, right? Okay, so the only way we know how to take an antiderivative right now is if we can undo something that we know the derivative of. So we've been focusing on maybe the antiderivative trig functions, basic trig functions, the antiderivative of 1 over x or any polynomial, or anything like logs or exponents that we can undo easily. So for example, if I want the antiderivative, the integral of secant squared x dx, what is it? Tangent of x plus c, right? But if I throw this at you and say secant squared of 2x dx, now it's not so convenient. I mean, obviously you would want to say what? Tangent of 2x and then plus c. When I go to take the derivative of that to see if it matches, what rule am I going to have to use? Chain rule. So what would the derivative of this be? Secant squared of 2x times 2. So if I want to take the derivative of this, I get the 2 out front. So what do I have to do to this to make it match that? Maybe throw a 1/2 out front there. And when I do that, the derivative of this would be 1/2 of secant squared 2x times 2. And so we cancel out and we're left with that, right? So I'm going to show you a little bit more succinct, complete way of accomplishing that. But it gets pretty complicated if you're not paying attention. Okay? Let's do some practice with derivatives first because you guys need it. Agreed? Yeah, okay. So let's try these. D dx of natural log of x times secant of x. I'm going to give you 5 seconds to come up with an answer. You can write it down in that time, but you should know the answer now though, right? What rule? Product rule. What's the derivative of the first? 1 over x times the second, secant x, plus, what's the derivative of secant? Secant x tangent x times natural log of x. Okay, so 1 over x times secant x plus natural log of x times secant x times tangent x, and that is the product rule. What about this guy? 3 to the x over cosine of x. We just did something like that on the one-up. Okay, so the top is an exponential. So what's the derivative of the top? 3 to the x times natural log of 3, and then times the bottom, cosine of x, minus the derivative of the bottom, which is negative sign. So it would be minus negative sign, which turns into plus sine of x, times 3 to the x, and that's all over cosine squared x. So rewrite it as d dx of 3 to the x times secant x, and then product rule from there. So that would be what? 3 to the x natural log of 3 times secant of x plus tangent x secant x times 3 to the x. That is true. Chances are, if it's multiple choice, it's not going to look like this because they're just testing, can you do the quotient rule here, generally speaking. But that brings up the question, is that equivalent to that? Yes. Can you manipulate this to look like that? That's good practice. Well, and change the secants. So this would be 3x natural log of 3 over cosine plus sine of x over cosine of x, and then that goes cosine of x and then 3 to the x, right? And then we can't add them until we have a common denominator, so we have to multiply that by cosine. So 3x natural log of 3 times cosine of x over cosine squared x plus sine of x times 3 to the x over cosine squared x. So that's yes. Okay. All right, but what general rule are we using here? Quotient rule, or product rule if you want. What about this one? Natural log of tangent of x squared plus 3. So, what rule? Chain rule. So it's going to be the derivative of the natural log function. So it's 1 over tangent of x squared plus 3. And then all of that times secant squared of x squared plus 3. And then times 2x. And we can simplify that by putting it as one fraction, right? And that is, again, the chain rule. Yes? Okay. How do we undo these? So we know how to undo the power rule. Undoing the power rule, if I say 7x to the fourth, and I want to take the integral of that, or the antiderivative of that, what do I do to undo the power rule? You add 1 to the exponent, so we'd say 4 plus 1, and then what do we do with the 7? Divide it by the new exponent, right? And then plus c. So that's how we undo the power rule. That one's easy. But how do we undo the product rule, the quotient rule, and the chain rule? Well, we are not going to learn how to undo the product rule or the quotient rule. I'm sorry to disappoint. Well, because you need to know how to take the derivative of it. Oh, right. Did you get those right? Okay, good. But we are going to learn how to undo the chain rule. Okay, and that's by U-Substitution. The anti-chain rule. All right, so obviously when we look at a function, to take its antiderivative, it's not as easy as we would like, right? And so if we can't take the antiderivative, what do we do? Integral form, right? We write it in integral form with the definite integral? Yes? Okay, but don't fall into the trap, oh, I don't know the antiderivative of that, so therefore I'm just going to put it in integral form and call it done. No, there will be functions that you should know how to take the antiderivative of, but they're a little bit more complicated. So don't just automatically revert back to integral form. Okay? Let's see if we can rewrite a function and make it easier to look at that way. Okay? Let's take a look at this. So I want the integral of cosine of x times e to the sine of x dx. Why is there an indication that this is the derivative of a function that used the chain rule? What's the chain rule say? It's the derivative of the outside times the derivative of the inside, right? So is there any pluses and minuses in that? No, it's just you're multiplying two derivatives, basically, right? This is an indication that it's the opposite of the chain rule because it's just multiplication. Okay? So here's what I'm going to do. Do you know the antiderivative of cosine? Sure. Do you know the antiderivative of e to the something? Yes. Do you know the antiderivative of sine? Yes. So you know the antiderivative of all the pieces. But what do you think is the prominent function in the original equation here? E to the something. Because the cosine and the sine are related to each other, right? Okay. So I'm going to say let u equal sine of x. Don't stress right now, just follow. And then you'll hopefully see something here. Let's say u equals sine of x. You guys okay with that? U is a function. U is a function, x is the variable, right? So u is the function, x is the variable. How do I take the derivative of u in respect to x? You listen to my words. How do you take the derivative of u in respect to x? Okay, so another way of saying the derivative would be what? Du dx. Okay, so du dx equals what? Du dx equals cosine of x, right? Okay. You guys agree with that at least, right? If I say u equals sine of x, then du dx will be cosine of x. Get away from the idea of just u prime, because we need this notation to help us make sense of this. Now, why did I choose u to equal sine of x? Just because random? No. Because I see the exponent on e to the something is the sine of x. Okay? Now, I'm going to multiply both sides by dx here. What do you get? Du equals cosine of x dx, right? Now, I'm going to rewrite, what I'm going to do now is substitute values back into my original equation. So I have the integral, better marker here. The integral of, what is it? Cosine of x times e to the sine x dx. Okay. I'm going to rewrite that integral with values that I just created. Now, I don't know how to take the integral in respect to x, do I? But maybe I know how to take the integral in respect to u, because I knew how to take the derivative of u. So let me rewrite this. Let's rewrite this as the integral of e to the sine of x times cosine of x dx. You agree that those two things are the same? Now let's substitute values in and see what we end up with. The integral of, is there anything that says I can replace e with anything? No. E. What about sine of x? Yeah, I can replace sine of x with u, because u equals sine of x. Times, is there anything I could substitute cosine of x with? Kind of du dx. But look at that last line. It says du equals cosine of x dx. There's cosine of x dx. That whole thing can be replaced with du. And so now this is way easier, isn't it? What is the integral of e to the u du? It's the antiderivative of e to the u. E to the u plus c.
Why do you get rid of the u?
Think antiderivative. What's the antiderivative? E to the something. E to the same thing, right? And then the plus c is just plus c. So that's it. That's the answer. Except for, this is in terms of u. I want it in terms of x. So, yeah, u equals sine of x. So what's this going to say? E to the sine x plus c. That's it. Done.
I knew that answer before.
What do you mean, why did I get rid of the du? Okay, so let's take the antiderivative of x squared dx. What do you get? Why'd you get rid of the dx? Why'd you get rid of the dx? Because when you're taking the antiderivative, remember, the derivative function is this, right? That's like saying this. When I take the antiderivative of this, what does this become? Where did the dx go? It's gone because that's part of the derivative. Okay, it goes away. Okay. All right. So let's go back up there. So we could say instead of the integral of cosine of x e to the sine of x, we could just say it's the integral of e to the u du because I replaced a bunch of stuff. Say that one more time. When you take the antiderivative, the du disappears. It's gone. This one up here? Okay, so go back. I hear what you're saying. I see it. So you see here, I've got du equals cosine of x dx. Well, here, this is cosine of x dx. I'm replacing cosine of x dx with what value? Just du. Du equals cosine of x dx, according to that, right? So I took this value and I plugged it in for this. So this all gets replaced with du. There's no dx left. No? Because why is there a dx still left? Yeah, cosine of x. How can I make this click?
The dx is still implied because it's included in
The dx is replaced with the cosine of x because du is equal to this whole thing. It's not just equal to cosine of x. If du equal cosine of x, if du equals cosine of x, then I agree. This would be e to the u times du dx. Because the only thing I'm replacing here is cosine of x. But I'm replacing all of this with du. Okay, well, when you get more practice, when we do more practice, you'll see. What should I be doing all along the way to make sure I'm right with this? Take the derivative. Let's do that. What is the derivative of e to the sine of x? E to the sine of x times cosine of x because of the chain rule, right? So let's see here. Did I actually do that here? I don't think I did. So taking the derivative of that, d dx, of e to the sine of x plus c would be e to the sine of x times cosine of x. What's the derivative of c? 0. And so you can see that's what I started with for the integrand, right? You guys okay with this? Okay. So the idea, let's go through the steps of this. It's a little bit, there's a lot of steps, but once you get practice with this, and we're going to spend a few days on this, okay? Hopefully it becomes clear, okay? The first thing you want to do is identify these functions as the result of chain rule. And the key to all of this is identifying the innermost function. So in this case, there's a product here, right? So this can't be the inside of anything, and this thing can't be the inside of anything because there's a multiplication sign there. What is the inside of this? The sine of x, because this is saying e to something. It's e to a function, right? So in this case, we identify the inner function. We say the inner function is u. So we set u equal to that inner function. That's why we said let u equal sine of x. What did we do after that? We set let u equal sine of x. That's step 2. We took the derivative of u in respect to x. What do we get? Cosine of x. Okay. So we took the derivative in respect to x. And then what do we do after that? Multiply by dx. So du equals cosine of x dx, right? Okay, so we're going to multiply both sides by dx. And then what did we do after that? We plugged what we could into, we replaced things, right? Okay, we substitute values in, okay? So we substitute into the original function, and then after we substitute into the original function, what do we do? You take the antiderivative, right? Take the antiderivative. And then after we took the antiderivative, what do we do? We plugged our original value back in for u. Okay? Substitute the original function back in, or the original value back in. You can't do this unless how many variables should you have? How many variables should you have in an equation? 1, right? In this case, what's the variable that we're integrating in terms of? X. In this case, it's u. You can't have an integrand that has a u in it and then in respect to dx. That doesn't make sense. It has to either be all u's or all x's, no matter what. If it doesn't, you can't do it. So something's wrong with your method if you have a mix. It's possible. And then it gets really gross. Maybe. That's a.
Maybe not.
Now that you ask. All right. This is important, okay? Like I just said, make sure that all the x values disappear. You don't want any x values left in the integral. We want to replace everything with just u values. Where? No, but like, okay, so once you get down to this point, you don't want this to say e to the u dx. You can't mix up the u and the x. Once you're here, you have to make sure it's in terms of u only. Then you can evaluate, and then once you're done evaluating, you can go to step 7 and plug in your original value for u. Since you said u equals sine of x, we just plug that in there. Okay? And again, what's the last step over all of this? Take the derivative and make sure it's right. Okay? Let's see what we can do here. Oh, that's another point. Again, you want it the integral of g of u du, not g of u dx. Again, because you don't want to have cross variables. It's all got to be the same variable. So you want it all in terms of u, not a mixture of u and x. Are we okay with this? For now? All right. I'll do this one with your help. Actually, I'll give you a minute. What's the first step? Identify the innermost function. What kind of function does this look like? Remember, we're doing like the anti-chain rule. So is this like polynomial? Is it exponential? Is it trig? It's going to be a chain rule. What is the innermost function? X squared minus 1. So you say, let u equal x squared minus 1. All right, what is the u value, did I say? X squared minus 1. Why did I say u equals x squared minus 1? Because it looks like it's the innermost thing. It's in parentheses, number 1. And think of it this way. What's the next step after you identify your u? Take the derivative. What's the derivative of x squared minus 1? Oh, do you see the 2x in the equation? Okay, so that's helpful.
Well, I think I figured it out.
Then you'll eventually get to a point where you can't integrate. You'll have an equation that has u's and x's in it. Basically, yes. At this point, eventually you'll get used to it and you go, okay, I can see it. Okay. So let u equal x squared minus 1. We're going to take the derivative, so it'll be du dx equals 2x. Then what do? Multiply both sides by dx, so you end up with du equals 2x dx. Now, after step 4, what do? Substitute back in, and our goal is to get rid of all the x's. I can replace the x squared minus 1 with just u, so that'll say u to the 4th. But what about this 2x? See how I got 2x dx here? What is 2x dx equal to? Du. So what will the equation now say? Okay. The integral of u to the 4th du. Do you guys see that? U is x squared minus 1, so that's where we got the x squared, that's where we got u right there. And then du is equal to 2x dx, so that replaced the 2x and the dx there. What's the antiderivative of u to the 4th? 1 over 5 u to the 5th, right? And then plus c. And then what's the last thing we do? Plug in u. What's u? So it'll say 1/5 times x squared minus 1 to the 5th plus c. Okay, I'm going to show you a different method that might see it. But see, you know how I put u right here? Okay, what's left? I've got a 2x here and a dx there. I've got to get rid of both of those. Because I can't have a u and x in the same equation. Well, look down here. 2x and dx can all be replaced with du instead. Okay. Now, I'm gonna show you a little bit alternate method. It's going to be, we're going to still use let u equal x squared minus 1. And then, as a result, du equals 2x dx, right? You guys okay with this? To keep it maybe simple for you, let's just get dx by itself. Just get dx by itself. How would I get dx by itself? Divide by 2x. So as a result, we end up with I'll write it like this. 1 over 2x du equals dx. You follow me? Now let's substitute. So we have an integral of 2x times x squared minus 1 to the 4th dx. Let's substitute anything we can. Can I substitute the 2x? Is there anything that says no? So 2x times, can I substitute the x squared minus 1? U to the 4th. Can I substitute dx? With this, right? So it would say times 1 over 2x du. You guys okay with that? And then you can see the 2x and the 2x here reduce, and you're left with the integral of u to the 4th du. So that might make it a little bit easier for you to see.
So, like, now I have two ways, and it's kind of confused me doing it this way. Do we need to know how to do it this way, or is it like, can we just know how to do it the other way? Like, you know what I'm saying?
Okay, this is more of like I can see it in my head. So therefore I can skip intermediate steps that's on the projector. Here is I can't see it so well, so I'm just going to run through a process, isolate dx, and then once I have dx here, I'm going to replace it with that. And then eventually, if I did it right, the x's will reduce and disappear on their own. And so if you end up with something, again, like if you end up with this, can anything be reduced here? No, so you know this is wrong. You know that you did something wrong along the way. Okay? All right, let's see how you do it. Again, check the derivative. What is the derivative of 1/5 x squared minus 1 to the 5th plus c? Fair enough. Let's do it step at a time. 1/5 is a constant. So what do I do with the x squared minus 1 to the 5th? 1/5 times 5 times x squared minus 1 to the 4th times 2x. So the 5ths reduce, and I can move the 2x out front. So 2x times x squared minus 1 to the 4th. And that's what we started with, so we're good. Okay? So that reduces. We're good. Any questions? Okay. It is. That's a check mark, by the way. That's a backwards check mark.
Oh, no.
Give these a shot. I didn't make it crazy. Don't worry. It's okay. It's okay. This is probably the best way to write it, right? Because you're taking the sine of 3x, right? What is the innermost function? So let u equal 3x. We'll take the derivative, so du dx equals 3. And now our goal is to isolate dx. So du equals 3 dx. And we'll divide by 3. Now some of you guys were saying du over 3, right? Look at our original. Do you ever have the dx over a number? No, you always just wanted to say dx or du at the end. So let's rewrite it as 1/3 du equals dx.
Yeah, but then you even plugged it in, and I thought you can't cancel out.
So then now we plug in, so it'll be the integral of sine of u, and then what's in place of dx? 1/3 du. So that's that. And I notice the 1/3 is a constant. So let's rewrite this. If I want to, I could just do 1/3 sine of u du. Are all my x's gone? So I'm good to go. Can I take the antiderivative of this easier than that? Yeah. Because the constant, just bring it out and bring it back in later, right? What's the antiderivative of sine of u? Negative cosine of u. And then remember the 1/3, right? And then plus c. So you get negative 1/3 cosine of u plus c. And so we end up with negative 1/3 cosine of 3x plus c. Okay? Yeah. That's a good question. Okay, so you guys try 2 and 3. Number two. What is the innermost function on number 2? 7x minus 2? Okay, the derivative of that would be 7 dx, right? Du equals 7 dx essentially, right? And then if you need to solve for x, but when you go to plug it in, you should get the integral of 4u to the third du. Are we okay with that ultimately? Take the antiderivative. What's the antiderivative? U to the fourth plus c. And then we'll plug in 7x minus 4. If I take the derivative, what rule am I going to use? The chain rule. That's why this is the anti-chain rule. If I take the derivative of this, it's going to be 4 out front times this to the third, and then times what? Times 7. So if I brought the 4 out to the front and I multiplied it by 7, I end up with that 28. So I know I did it right. Okay. Number 3, what's the innermost function? Okay, so the integral of x dx over x squared plus 1. First thing I'm going to do is rewrite this. X over x squared plus 1 dx. Because that's what it should look like, right? Now we'll say let u equal x squared plus 1. The reason I wanted x squared plus 1 is because the next step is to do it. Take the derivative. If I let x equal u, we're not getting anywhere because x and u are basically the same thing, right? Same power and everything. And besides that, when I take the derivative of x, what do I get? I don't get the x squared that I need to cancel out. So du dx equals 2x, and then we can say 2x dx. Isolate dx if you need to, so you get 1 over 2x du equals dx. And then substitute. So we end up with the integral of, can I replace x? No. X over, can I replace x squared plus 1? U. Can I replace dx? Dx is that, so 1 over 2x times du. You guys okay with that so far? The x is reduced, you're left with the integral of, yeah, those reduce, so you're left with 1 over 2u du. And so this brings up the point, I might have to do a second U-substitution because the bottom isn't just u. Except for the fact the bottom is just 2u. So what could I rewrite that as? 1/2 times 1 over u du. What's the antiderivative of 1 over u?
ln u.
ln of what?
U. Oh, absolute u. I wrote that on my We wrote that.
So your answer would be 1/2 natural log of the absolute value of x squared plus 1 plus c. I have to work it out. Hold on. I got to work it out. Let's see if this matches first of all.